Picture this: it's early in the morning and you step into your garden. The air is cool and fresh. The leaves sparkle with beads of dew. Then you notice it: a dark patch on a tomato leaf, a faint yellow tint creeping across your chili plant. Instantly, questions race through your mind: is something wrong? Could this be a disease? Like most of us, you grab your phone and start typing frantic searches. Brown spots on tomato leaves, meaning, only to be buried under pages of confusing, contradictory advice. That was exactly the frustration I faced last year. I love growing plants, but I don't have a botanist on speed dial. Every time a leaf turns yellow or a stem droop, I wasted hours guessing. Then the idea hit me. What if a computer could look at a plant photo and tell me in seconds what species it is and whether it's healthy? Fast forward to today, and the idea has grown into a full project: a farming chatbot powered by deep learning. But here's the twist: it isn't a flashy mobile app, it lives right inside the terminal. No heavy interface, no endless clicks. Just type, hit enter, and watch the intelligence unfold. Behind this simple conversation lies serious tech. Using PyTorch and transfer learning, the chatbot combines two powerful neural networks. One trained to identify plant species from hundreds of images stored in a folder called data, another trained to detect plant diseases from dedicated dataset with training and validation splits. Together they create a real-time plant doctor that runs on your own computer. Here's how a real session feels like. The program greets you like an old gardening friend. Good afternoon. Ready to check your plants? I choose the option 3, detect both species and diseases, and upload a picture of tomato from my local drive. In seconds, the terminal replied. Fun fact: tomatoes are typically fruits, not vegetables. Species: tomato with a confidence of 61%. Diseases: wheat mite with a confidence of 85%. And I advise: apply miticide and practice crop rotation. It didn't just give me the name of the plant, it offered quick fact and gave a confidence percentage, scanned for possible diseases, and even suggested treatment. When I typed, "Tell me more about tomatoes," it generated a rich 20-point report covering everything from soil pH and growth cycles of nutrition and historic trivia. I tested it further with rice, wheat, and random leaves. Each time it detected species and potential diseases with remarkable speed. Then, just for fun, I pressed back to the main menu and tried the built in quiz. 5 quick questions later, the chatbot scored my answers and cheered on me. All of this: species detection, disease diagnosis, fun fact, history, interactive Q&A happens in plain terminal window, powered by Python, PyTorch, and a clever training pipeline. In this video, I'll walk you through every layer: how the datasets are organized, how the ResNet 18 architecture works, and how simple commands like retrain or history triggered powerful machine learning pipelines. If you want a quick recap of how ResNet 18 works, check out this video from Code with Arohi: Image Classification using ResNet 18 and PyTorch. Open app.py and write the following code: import OS, import SYS, import CSV, import time, random, torch, torch.nn as nn, torch.optimum as optimum, torch vision, import dataset, transforms, and model. From torch.utilities.data import data loader. From PIL import image. From datetime import datetime, import warnings. From fuzzy wuzzy import process warning.filter warnings ignore. OS stands for file and path utilities. SYS for system IO. CSV for reading CSV files. Time is used for delays and timestamp. Random for random sampling and shuffling. Torch, torch.nn, and torch.optimum for PyTorch core neural network layers. PyTorch Vision for dataset helpers for image folder and image transformation, data loader for batch loader for datasets, pil.image for image opening and conversion, datetime for greeting message, warnings and warnings.filter warnings to silence library warnings, keeps terminal output cleaner, and fuzzy.process fuzzy string matching utilities used to map users' requests to closest plant or disease names. Configuration block, data plant or data disease, folder names for species data and disease data. Model file prefix for saved model file names used to find load latest model, batch size, EPOS and LR for training the hyperparameters. Device, select the GPU if available, otherwise CPU. Plan details CSV file name used for extra planned metadata, history, and in-memory list storing recent prediction result for session history. Fun fact dictionary: a mapping for lowercase plant name keys to short fun fact string values, used to print a friendly fact when a recognized species has an entry here. Disease type dictionary: map disease/class names, the class string used in the disease dataset to short additional advice strings used for disease prediction to show recommended action for the detected disease. Typing animation helper defines type print that prints text like a human typer. Write characters one by one with delay second pause. Uses sys.stdout.write and sys.stdout.flush to control output without adding extra new lines. Useful for nicer UX in the terminal. Color confidence helper converts a float confidence to a colored percentage string. 0.8 meaning 80% it will be green, 50% it will be yellow or else red. Uses ANSI escape codes, works in most terminals. Load plant details CSV. Initialize plant details dictionary. If plant details.csv exists, open it and read rows as dictionaries with dict reader. Stores each row key by the crop name column. Each value is the full row dictionary so you can access various attributes in get plant info. Get plant info and get tip. Get plant info plant name returns a formatted multi-line string of details of all CSV columns except the crop name. If not found, returns the default message. Get tip name and mode. If mode equal to plant, returns the plant CSV info, else returns the disease advice for disease tip defaulting to a generic line. Greeting function uses current hour to print the time appropriate greeting through type print. Dataset preparation planned defines image transforms for training, resize, augmentation, flip and rotation, tensor, ImageNet normalization. Dataset.image folder accepts data, class subfolders and image. It builds dataset.class to IDX. Data loader batches and shuffles. IDX to class inverts class to IDX, so prediction indices can be mapped to class names. Returns dataset, loader and mapping. Dataset preparation for disease. Similar to plant dataset but uses separate train and validation folders and different transforms for validation, no augmentation. Returns train and validation dataset loaders plus mapping. Model creation using ResNet 18. Loads pre-trained ResNet 18 ImageNet weights, freezes all parameters by setting require gradient equal to false, so only the newly created final layer trains. Replaces the final FC with the linear num feature and num class matching the dataset class. Moves model to device, sets criteria to class entropy loss and optimizer to atom, so only model.fc parameters since rest are frozen. Returns model criteria optimizer ready for training. Load latest model helper. Scans current working directory for files starting with model prefix like plant model v. If any exist, sorts them and picks last item as the latest. This works if file names include version timestamp that sort correctly. Loads the weight into model object using torch.load map location equal to device returns true if loaded else false. Predict image interface sets model to evaluation mode, disables dropout and batch norm updates, open image and converts to RGB. If fails, file meshing or corrupt, returns none. Applies standard transformation, adds batch dimensions and move tensors to device. Runs forward pass inside torch.nonGradient to save memory and avoid gradient composition. Outputs are logics. Apply softmax to get probabilities. Torch.max returns the top probability and its index. Convert confidence to Python float with item. Maps predict index to class name. If confidence value below threshold, default is 50%, returns unknown plus confidence, otherwise returns label and confidence value. NLP questioning handling with fuzzy matching takes user text and converts to lowercase, uses fuzzy.process extract 1 to find the closest plant name in the plant details and a similar score. If score greater than 70, turn threshold, assumes user likely referred to the plant and returns the CXP details, get plant info. If not, does fuzzy matching against the disease name. If match, returns disease advice. Otherwise checks the keywords care, hello, thank you, quiz and returns canned replies triggers start quiz. Quiz data and helpers. Quiz question list of question dictionaries with question options, answers, shuffle quiz options. For each question, remembers the correct option value, shuffles the option list randomly, and then updates the answer index so the correct option still maps to the right index after shuffling. Ensures correctness even after reordering choices. Immediately shuffles the quiz question option at the program start. Starts quiz. Greets user, picks 5 random questions, prints each with shuffled options. Input validation ensures 1 to 4. Awards 20 points for correct answer, prints progress bar, and final score plus a motivational quote. Main chatbot interface. Top level loop shows menu and reads user choices. If exist, goodbye and break. If invalid choice, prompt again. If user chooses species, data or both, prepares dataset and creates models accordingly. Calls prepare dataset to get loaders and class mappings. Calls create model num class to estimate a fresh model for that domain. Load latest model attempts to load any previously saved weights for that model if found. Note that the code currently always creates a new model object, then tries to load weights into it. That's fine. If choice equal to 4, runs the quiz and continues to the top level menu. Input loop while in a mode. Reads user input in the selected mode. Commands exist or quit. Exist the whole program. Back to return to the main menu. History to print the last 5 items from history. Converts backslash to forward slash and strips codes splits comma separated parts is image to check whether every provided part ends with a known image extraction. If is image for each path checks file exists, else print error. If mode includes species detection 1 or 3, calls the predict image plant model and gather plant info and returns the CSV info or default. If the level matches fun facts key, print fun facts. If mode includes disease prediction 2 and 3, calls predict image and append the disease advice. Print result via the type print, append a history entry and print a divider. If not an image, treats input as question and calls handle question, which may use fuzzy matching or start the quiz. Program entry chatbot interface kicks off the interactive chatbot session.